Hey guys, I hope you all are doing good. In this lecture, we will be understanding what is a direct proof and we will understand what are contrapositive proofs, right? These are the simplest proofs that to understand. So this video should be pretty easy and pretty short, right? Both these proofs, for both of them, I'm going to be solving two examples and I'll give some practice questions towards the end, right? I'll put all the answers in the description. So let's start with what is a direct proof, right? Direct proof of an implication P then Q follows this structure, right? So the basic understanding is that I'm supposed to go from P and reach the conclusion Q, right? I need to follow some logical structure for it. By now, I hope you understand the word logical structure, right, and logical flow. If you have covered predicate logic, propositional logic in detail, right? So the first step is assume that P is true, use logical deductions to show that Q must also be true. So the basic point is that I need to prove something that if this is the assumption, then this is the conclusion. And in order to reach that conclusion, what I'm supposed to do is I'm supposed to find any things that I can, right? So all the all the research that I can put into understanding P and what conclusions that I can find, and using whatever results I get, I need to reach the conclusion Q, right? I know this might sound very strange, but I think this example will make things a lot more clearer. So let's try to understand this example, right? I need to prove if n is divisible by 4, then n is even, right? Now I know this is something that we all already know, but let's say you get this question and you need to prove something. This is just a simple example of how a direct proof works, right? Okay, so let's start with the proof, right? We are assuming P is true. So let's assume n is divisible by 4, right? I made the assumption that n is divisible by 4, right? Now, what can I figure out from this sentence, right? What are my findings that I can find? So the one thing that I find is that if n is divisible by 4, then I can write it down as n is equal to some value 4 multiplied by k. Let's try to understand it, right? N is divisible by 4, then that means it has to be some multiple of the value 4, right? Let's try to understand it. Let's say I have, if n is equal to k, then this should be equal to 4 multiplied by 2, right? So n over here would be 8, 4 would be the value 4, and k would be the value 2, right? So if any number is divisible by 4, then it has to be that we can write it in this form, right? 4 multiplied by the value k. So I hope you're able to understand this form, right? Okay, moving on. So the basic point is that using my assumption, I figured out that I can write n as 4 equal k. Now it's very important to understand that I write down what is this value k, right? Just like I said in the previous video, whenever we are writing down the proofs, I need to talk about everything that I'm writing down, right? Any assumptions that I'm making and any values that I've introduced, I need to introduce them and explain them very clearly. So in this case, I write n equal 4k, where k is future value. Okay, now, so I've reached the point that n is equal to 4k. Now let's try to solve and figure out if that n is even. So first thing, how do I figure out if a number is even or not, right? There's a very simple way to understand. If a number is even, then it has to be divisible by 2, right? And if a number is divisible by 2, if you think about it, if number p is then p equals some value 2k. Does that make sense? So if a number is divisible by 4, then it is 4k. If a number is divisible by 2, then it has to be of the form some 2k, right? For example, if I take the value 2, which is the even value, I can write 2 as 2 multiplied by 1. I can write 4 as 2 multiplied by 2. So every even number can be represented as 2 multiplied by some integer value, right? So the basic point is what I'm supposed to do is I'm supposed to maybe reach that point that I can represent n equal 2 multiplied by some value, right? So if I can do that, that means I've proven that it is an even value. So once again, to prove n is even, I need, I'm just writing this down. You don't have to write down this in a proof usually. This is just for explanation purposes, right? So to prove n is even, I need to show n is equal to some value 2 multiplied by, let's say, m. Okay, now let's try to understand what I'm supposed to do, right? I already know n is equal to 4k. So if you think about it, I can write this as n is equal to 2 multiplied by 2k. Does that make sense? So this is basically the form n is equal to 2 multiplied by m. Hence, since I have reached this point where n is equal to 2m, okay. So let's try to understand everything once again. I'm sorry if this is if you're not able to understand it, but I'll explain what I've written down, right? So I was supposed to prove if n is divisible by 4, then n is even, right? So if a number is divisible by 4, then it is of the form this. And if a number is divisible by 2, then it has to be of the form 2 multiplied by k, right? This is just, there are going to be a lot of things that you need to know before you solve the proof. So for example, representation of a number divisible by 4 should be 4k, and even number is represented as 2k, right? Okay. So I know I have the value 4k and I'm supposed to reach some form of 2 multiplied by some value, right? And that is how I'll be able to prove it. So what I did is, I started with n equal 4k. I basically did 2 multiplied by 2 multiplied by k. So I get n equal 2 multiplied by bracket value 2k. This gives me n equals some 2 multiplied by m, and hence I've proven that it is an even number, right? Since it is 2 multiplied by some integer value m, hence it has to be the case that it is an even number, right? So I hope you were able to understand this example. Now let's take a look at another example. Okay, now let's take a look at another example. This is a very similar example. So I think you guys should be able to solve it. So I would suggest if you can pause this video and try to solve this question yourself, right? Okay, now let's continue with this question. Given if x is odd, then I'm supposed to prove that x square should also be odd, right? Okay, one thing, just like the previous example, I need to show the representation of an odd number, right? So if you don't know, then odd number is equal to 2k plus 1, where 1 is, sorry, where is an integer. So basically, when there's an even number, we represent it as 2k, and when there's an odd number, then the representation is 2k plus 1, right? So just some basic things that you need to understand. Now, what the basic idea over here is, right? I have some odd value which could be of the form 2k plus 1. What I'm supposed to do is, I'm supposed to solve x square and then also turn it into a form like 2 multiplied by some value plus 1, right? If I reach that kind of a form, then I can say that it is an odd number, right? So once again, this is the representation of an odd number where k is an integer. When I square it, what I'm supposed to do is, I'm supposed to convert it into this kind of a form once again. And I'll try to explain how it works. So let's start with the proof, right? First thing, just like given over here, assume p is true. So let x be odd number, x equal to k plus 1, where k is some integer. Now, even though this is one of the ways I can represent it, it is also another way I can write it as k is an element of z, right? What this means is, if you remember from the sets, I'm saying k is an element of the set of the integers, right? Which basically means k is some integer. Okay, so x is equal to 2k plus 1. Now let's solve for what is x square, right? X square would be equal to 2k plus 1 square. If you remember a plus b whole square, then it is a square plus b square plus 2ab, right? So this is going to be 2k square plus 1 square plus 2 multiplied by 2k, right? So this gives me 4k square plus 4k plus 1. Now, how do I reach the representation to some integer plus 1, right? 2 multiplied by some integer plus 1. That is a representation that I need to convert it to. Now, let's take a look at this, right? 4k square plus 4k. Maybe I can take 2 common in these two elements. So this gives me 2k square plus 2k, right? And I can leave this plus 1 alone. Now, I've reached that representation. Maybe I can say this is equal to 2m plus 1, where m is equal to 2k square is 2k, right? Now think about it. If k is an integer, then 2k square plus 2k should also be an integer, right? I'm not making any divisions, so this would not result in some decimal value. So 2k square plus 2k should always result in an integer in this case, right? Because my assumption is that k is an integer. So I have represented this as 2m plus 1, where m is 2k square plus 2k. So the basic point is that this m would be an integer which is multiplied by 2, and we are adding a 1 to it. This is the representation, and since it is of this representation 2m plus 1, then it has to be that it is an odd number, right? Once again, I'll try to give a summary of how we started it. Suppose to prove x is odd, then x square is odd, right? What is the representation of an odd number? Odd number is basically 2 multiplied by some integer value plus 1, which is basically an even number, and we add 1 to it, it would result in an odd number, right? Okay, so I started with x equal 2k, I squared the value, which gave me this result. Then I took 2 common to reach this representation, right? And finally, I can say, hence, proved x square is odd. So start with the assumption and finally reach the point that the conclusion should also be true. So from these two examples, I hope you are able to understand how direct proofs work. Very important thing to understand is these proofs are usually kind of tough to understand. So the more questions you solve, the better it is, right? And once you keep solving questions, maybe 10 to 15 questions on each single type of proof, then you would have a good idea about how basically we solve questions on proofs, right? Okay, moving on, let's try to understand contrapositive now. Okay, now let's try to understand what is the contrapositive proof. Again, very easy to understand. If you understand how the direct proof works, then this should be very easy to understand, right? There's just a slight difference in this case. Instead of proving P then Q, we prove it's contrapositive, right? So if the original is P then Q, we prove negation of Q then negation of P. Let's try to understand why this works, right? So the basic thing is, if you try to prove it, P then Q is actually equivalent to negation of Q then negation of P. So a quick task or a quick exercise could be, you try to solve for their truth tables and you'll find out that all their truth values are same, meaning that P then Q is actually equivalent to negation of Q then negation of P. This over here is the contrapositive of P then Q, right? So I hope you understand what is the contrapositive. It is basically take the right hand side to the left hand side or twist them around and then do the negation of it, right? Okay. Now, basically they are equivalent to each other. So the idea in what is a contrapositive proof is that maybe I am not able to flow from P to Q and reach the conclusion. So maybe I can start with assuming that Q is actually false and then prove that P is also false in that case, right? So let's try to understand this with this first example. Okay. So if A square is even, then A is even. Now you can try to solve it the direct way, just like a direct proof. But the problem is that you won't be able to do it in an easy way, right? So instead, what I'm going to do is I'm going to flow the opposite way around and with the form of negation of Q, then negation of P. So think about what is the negation of Q in this case, right? Negation of Q would be A is odd. So my assumption is going to be that A is odd, right? Let's assume A is odd value. Then A is equal to 2k plus 1. Okay, why did I assume k is odd in this case and why something different, right? Think about it. When I told you about what is negation, negation basically means the opposite of something, right? So if A is even, then the opposite is going to be A is odd. Similarly, if I say A is a happy person, then its negation is going to be A is a sad person, right? So you're basically in the negation, we are going from the opposite of something, right? Whether it's in English or in mathematics. So A is even, what I'm going to do is I'm going to directly prove negation of Q and reach the conclusion negation of P, right? So negation of Q is A is odd. So I make the assumption A is odd. Then A is going to be 2k plus 1. So I hope you're able to understand until this point how exactly everything works. Now, let's solve for A square in this case. So A square is going to be 2k plus 1 square, which is equal to 4k square plus 4k plus 1, right? I can also say A is an odd value, or I can say A is not even, right? So maybe I can, instead of this, I can write not even. Then A square is going to be 2k plus 1 square equal 4k square plus 4k plus 1. This is equivalent to 2 multiplied by 2k square plus 2k plus 1, which is equivalent to 2m plus 1. So let's try to understand what I did, right? I started with the assumption A is not even. Then it has to be of the form 2k plus 1, which means it has to be an odd number, right? Okay. Then I solved for A square, right? And reached the conclusion that A square should also be of the form 2m plus 1. And now the best part about contrapositive is that since I've proved 2m plus 1, which is A square is 2m plus 1, I'm just writing down this equation, right? So if you're trying to refer to an equation, then you can maybe give it a number, right? And then mention it in your statement, right? So I can say from 1, we can say A square is also not even. Hence, by contrapositive, yeah. So I hope you're able to understand what I've did. At the very end, I've mentioned that I've proved this by the contrapositive, right? So whenever you're proving something, make sure that you mention like what kind of way you're using to solve something. But this is simply going from the negation of Q to the negation of P, and everything else works exactly the same as the direct proof, right? So started with A is odd, assumed it's, which is basically meaning it is not even. So representation should be 2k plus 1. Proved that A square should have the similar representation, and hence it is not even. So I went from negation of Q and then reached the conclusion negation of P, which is the contrapositive. And since this is equivalent to P then Q, then it has to be that P then Q is also true, which in this case is A square is even, then A is even, right? So finally, I've mentioned from the one equation, we can say A square is not even, and hence by contrapositive, P then Q is true, right? So I hope you were able to solve these questions. Now I'll be giving some few practice questions for you guys to solve, and make sure if you have the time, then you spend your time solving all these questions, and I'll put the answers in the description, right? I'll be giving a bunch of good questions, so I would really, it would be really appreciated if you solve these questions. Okay. Okay. So I've given these four questions on the board. Before ending the video, I just want to mention one more thing. For any questions that you get in your exams or questions, right? It's the best way that you can start with trying to figure out whether we can directly prove it. If that's not the case, then you try some other way around, right? So maybe I get to prove something. I'll start by imagining if there's any way I can directly prove it. If not, then I'll take a look at other types of ways that I can solve it. So, quick hint for these exercises, right? These two uh, are going to be solved using the direct proof, and these two are using the contrapositive proof, right? The last one, the 4, might be a bit tricky to understand, but I think you guys will be able to solve it. Okay, so I'll see you guys in the next lecture. We will be covering proof by cases.